The position of two towns A and B on the Earth's surface are 36 degrees north, 49 degrees east, and 36 degrees north, 131 degrees west, respectively. A. Find the difference in longitude between town A and B. B. Given that the radius of the Earth is 6,370 kilometers, calculate the distance between town A and B. C. Another town C is 840 kilometers east of town B and on the same latitude as town A and B. Find the longitude of town C. A ship leaves an island 5 degrees north, 45 degrees east, and sails due east for 120 hours to another island. The average speed of the ship is 27 knots. A. Calculate the distance between the two islands. 1 in nautical miles, 2 in kilometers. B. Calculate the speed of the ship in kilometers per hour. C. Find the portion of the second island. Take 1 nautical mile to be 1.853 kilometers and the radius of the Earth to be 6,370 kilometers. The position of two towns X and Y are given to the nearest degree as X 45 degrees north, 10 degrees east, and Y 45 degrees north, 70 degrees east. Find A. The difference in longitude. B. The distance between the two towns in 1 kilometers. Take the radius of the Earth to be 6,371 kilometers. And 2. In nautical miles. Take 1 nautical mile to be 1.85 kilometers. C. The local time at X when the local time at Y is 2 p.m. A plane leaves an airport A 38.5 degrees north, 37.05 degrees west, and flies due north to point B on latitude 52 degrees north. A. Find the distance covered by the plane. B. The plane then flies due east to a point C 2,400 kilometers from B. Determine the position of C. A plane flying at 200 knots left an airport A 30 degrees south, 31 degrees east, and flew due north to an airport B 30 degrees north, 31 degrees east. A. Calculate the distance covered by the plane in nautical miles. B. After a 15-minute stopover at B, the plane flew due north to another airport C, 30 degrees north, 13 degrees east, at the same speed. Calculate the total time taken to complete the journey from airport A to airport C through airport B. Towns A and B lie on the same latitude in the northern hemisphere. When it is 8 a.m. at A, the time at B is 11 a.m. A. Given that the longitude of A is 15 degrees east, find the longitude of B. B. A plane leaves A for B and takes 3.5 hours to arrive at B, traveling along a parallel of latitude at 850 km per hour. Find 1. The radius of the circle of the latitude on which town A and B lie. 2. The latitude of the two towns. Two places P and Q are at 36 degrees north, 125 degrees west, and 36 degrees north, and 55 degrees east, respectively. Calculate the distance in nautical miles between P and Q measured along the Great Circle through the North Pole. Two places, A and B, are on the same circle of latitude north of the equator. The longitude of A is 118 degrees west and the longitude of B is 103 degrees east. The shorter distance between A and B measured along the circle of latitude is 5,422 nautical miles. Find the nearest degree, the latitude on which A and B lie. An airplane flies at an average speed of 500 knots due east from a point P 53.4 degrees north, 40 degrees east to another point Q. It takes 2.25 hours to reach point Q. Calculate 1. The distance in nautical miles it travels. 2. The longitude of point Q to 2 decimal places. The point P, 40 degrees south, 45 degrees east, and point Q, 4 degrees south, 60 degrees west, are on the surface of the Earth. Calculate the shortest distance along a circle of latitude between the 2 points. The position of 3 ports A, B, and C are 34 degrees north, 16 degrees west, 34 degrees north, 24 degrees east, and 26 degrees south, 16 degrees west, respectively. A. Find the distance in nautical miles 1. Ports A and B to the nearest nautical miles 2. Ports A and C. B. A ship left Port A on Monday at 13:30 hours and sailed to Port B at 40 knots. Calculate 1. The local time at Port B when the ship left Port A, the day and the time the ship arrived at Port B. A point M, 60 degrees north, 18 degrees east, is on the surface of the Earth. Another point N is situated at a distance of 630 nautical miles east of M. Find A. The longitude difference between M and N, the position of N. A tourist took 1 hour and 20 minutes to travel by an aircraft from town T, 3 degrees south, 35 degrees east, to town U, 9 degrees north, 35 degrees east. Take the radius of the Earth to be 370 kilometers and pi as 22/7. A. Find the average speed of the aircraft. B. After staying at town U for 30 minutes, the tourists took a second aircraft to town V, 9 degrees north, 5 degrees east. The average speed of the second aircraft was 90 degrees and that of the first aircraft. Determine the time to the nearest minute the aircraft took to travel from U to V. C. When the journey started at town T, the local time was 0700 hours. Find the local time at V when the tourists arrived. The position of two towns are 2 degrees south, 30 degrees east, and 2 degrees south, that's 7.4 degrees east. Calculate the nearest kilometer, the shortest distance between the two towns. Take the radius of the Earth to be 6,370 kilometers. The shortest distance between 2 points A, 40 degrees north, 20 degrees west, and B, 30 degrees south, 20 degrees west on the surface of the Earth is 8,008 kilometers. Given that the radius of the Earth is 6,370 kilometers, determine the position of P. Take pi to be equal to 22/7. The position of 2 points P and Q on the surface of the Earth are P is equals to 45 degrees north, 36 degrees east, and Q is equals to 45 degrees north, 71 degrees east. Calculate the distance in nautical miles between P and Q, correct to 1 decimal place. A tourist took 1 hour and 20 minutes to travel by an aircraft from town T, 3 degrees south, 35 degrees east, to town U, 9 degrees north, 35 degrees east. Take the radius of the Earth to be 6,370 kilometers and pi to be equal to 22/7. Find the average speed of the aircraft. A. Find the average speed of the aircraft. B. After staying at town U for 30 minutes, the tourist took a second aircraft to town B, 9 degrees north, 5 degrees east. The average speed of the second aircraft was 90% that of the first aircraft. Determine the time to the nearest minute the aircraft took to travel from U to V. C. An aircraft took from a point P 65 degrees south, 76 degrees west, and flew due north to a point Q. The distance between P and Q is 5,400 nautical miles. Determine the position of Q. The position of point C and D on the Earth's surface are theta north, 10 degrees east, and theta north, 30 degrees east, respectively. The distance between the 2 points is 600 nautical miles. Determine the latitude on which C and D lie. A ship left point P 10 degrees south, 4 degrees east, and sailed due north for 90 hours at an average speed of 24 knots to a point R. Take 1 nautical mile to be 1.853 kilometer and the radius of the Earth to be 6,370 kilometers. A. Calculate the distance between P and R in 1 nautical mile, 2 in kilometers. B. Determine the position of point R. C. Find the local time to the nearest minute at point R when the time at point P is 11 a.m. An aircraft took off from point A, x degrees north, 15 degrees east, at 0720 hours local time. It flew due west to another point B, x degrees north, 75 degrees west, a distance of 5,005 kilometers from Earth. After a stopover of 1 hour 30 minutes at point B, the aircraft took off and flew for 3 hours 40 minutes due south to a point C. The aircraft maintained an average speed of 910 km per hour for the journey from A to B and also from B to C. Take pi to be equal to 22/7 and the radius of the Earth to be 6,370 kilometers. Calculate the 1. Position of point B, 2. Position of point C. B. Determine the local time at point C when the aircraft arrived. A plane took 3 hours to fly from P 66.42 north, 30 degrees east, to Q 66.42 degrees north, 52.5 degrees east. Determine the speed of the plane in knots correct to 1 decimal place.